You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone. Thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Hello, everyone. I'm starting us off this week, and oh boy, howdy, do I have a doozy. Now,
All right.
Wow.
this is one of those topics that I was looking around, had some planned, was ready to go, and someone sent me something, and I'm like, wait, what? Hold on.
Gotta do it, right?
And then I'm like, well, I guess that really lovely topic that I had planned gonna be shelved for another day, because today I have to talk about the blue whale, because I cannot believe that we
I just
have
saw the article.
gotten to 55 episodes, and we have.
I did just see an article about blue whales too, and I'm super curious if it's the same one that Victoria saw and if it's the same one that Rachel saw.
It probably is.
The one I saw was not exactly about blue whales. It was about another creature interacting with blue whales.
The one I saw, I'll just say, was a totally killer article.
Yeah.
Ooh. I think we all saw the same article.
All right, let's hear about it.
All right, so obviously I went further into this, and I wanted to give us a little bit of a background on blue whales in general, because they're amazing, and then I need to talk about this article.
Okay.
Because it's truly just mind-boggling. So blue whales are the world's largest animal. They are not just now, just in general. Like in all of history, they are the largest
ever,
which is crazy. We didn't live in a time of dinosaurs, but dinosaurs have roamed the earth, and they were very large. So
did you hear this sort of statistic all the time?
Mm-hmm.
Is this by weight or length or all the above? Do you know like how they're classifying that as largest? Because there's so many ways you can measure an animal.
That is fair. I think they are measuring it by weight. From what I've been seeing, when they say biggest or largest animals, they talk about pretty much in the same breath, they talk about what they eat. So, and it's pretty astounding. Like, overall, it's a large animal. It's very long. It can grow up to 110 feet long, which is mind-bogglingly large.
How many Rachels is that?
A lot of Rachels.
A lot of Rachels.
A lot.
I would fill a room. But they can weigh up to 330,000 pounds.
Wow.
Which is it's so big. And they are found in pretty much any large ocean. And while I was going through some of the research on blue whales in general, I actually was finding out that there are 4 unofficial subspecies, potentially 5 unofficial subspecies of blue whale.
Oh, really?
Oh, okay.
I thought they were all one species, but I guess each ocean, more or less, gets its own subspecies. Because while they all eat krill, which is amazing because it's such a tiny little, because they're a baleen whale, they eat a tiny little thing.
I just have to interrupt. I know you said krill, but because of the audio, it sounded like you said they all eat crow. Which is a different thing.
It is a very different thing. Considering they can eat up to 6 tons of krill a day. If they were eating 6 tons of crow, that would be a lot of crows. But they are a threatened species, But that isn't exactly what I wanted to talk about today. Like blue whales on their own,
Right.
like it's kind of strange
Super
that
cool.
they're very large and they have really loud voices and eat a lot of food that is technically really, really tiny. But the article that we all saw today, you would think that they're really being that large. There isn't much that can kill you. There's not much that's gonna go after you other than like
humans.
Or a lot of issues that they have are like vessel strikes or getting entangled in fishing gear or ocean
humans.
noise. Again, human stuff. Scientists have now been able to document and have witnessed it. They have it on video. I watched the video.
Oh, wow. I didn't see the video. Okay.
Oh, me either.
It's
people who don't know are like, just say it. What happened?
They documented orcas, also known as killer whales, hunting actively a blue whale. And not just once.
Yeah, but that's not the weird part.
Separate times. 3. It was like the first time to really confirm that a blue whale was killed at the same time. And what Kirk was alluding to is what they got on video is while that blue whale was still alive, one of the orcas, several of the orcas were able to like go in and actually, warning, little graphic.
Yeah, cover your kids' ears.
They were able to go in and actually were like eating the tongue while the whale was still alive, while the blue whale.
Like attacking its mouth and eating its tongue.
While it was still alive. Yeah, it said that the whale took an hour to die, which just sounds awful.
That's not great.
Yeah, that isn't great.
That was the detail that got me. The tongue was pretty.
Yeah, that's pretty rough. But here's the thing.
But what an interesting technique. I mean,
right?
Man.
Well, here's the thing. This is one of 3 attacks that have been witnessed from 2019 to March 16th, 2021. So this is very, very recent. And it took them a long time, anywhere from 45 minutes to 90 minutes chasing and hunting and actively like getting the whale to go underneath the water and not allowing it to surface to breathe, like tearing parts of the whale off, slowing it down. And then after the whale died, they actually had up to 60 orcas feeding on it.
Whoa.
Yeah.
So not even the original pod of orcas, just a bunch of orcas from other pods all coming and eating this large mammal.
It's like I'm picturing like an all-you-can-eat buffet, you know, and you want to get your money's worth, so you really tuck in. Or maybe like this. I'm picturing like the state fair. Everyone's just gorging themselves. That's what I'm picturing here.
More or less, yeah. Well, I mean,
not great.
It's not, but it's amazing because, like, scientists thought they knew that they had eaten on already deceased blue whales, but there was no evidence of them actively hunting a blue whale before.
Orca are amazing animals.
Yeah.
They really, really are. But I wanted to touch on this today because it was truly phenomenal, and it's horrifying because you don't really want to see orcas like actively eating an animal that is still alive. Like, that's not great.
I mean, nature is not pretty.
No, it's not. But the steps that have been taken to be able to see this type of research and see this phenomenon happen, not once, but 3 times, and confirm and find something new about the largest creature on the planet. Truly, science is amazing, and hats off to those researchers, truly.
Did you have any info on like where in the world this was happening?
Australia.
No wonder you were pausing so long.
Yeah.
You had a funny expression on your
Of
face.
course.
It was off
Of
the coast
course.
of Western Australia.
Yeah, of course it was. It wasn't a setup. I really didn't know.
I know,
That's
I
amazing.
know. I saw that it was Australia and I was like, oh, they're gonna ask.
Of course it was.
Yeah, and I just want to talk about, or I just want to give credence, or not credence, credit to the paper, which was quite literally just published last week for when we're recording. It's the first 3 records of killer whales killing and eating blue whales, by, oh goodness, John Totterdahl, Rebecca Wellard, Isabella Reeves, Brody Eldison, Pia Markovic, Machi Yoshida, Ashley Fairchild, Gemma Sharp, and Robert Pittman. They all did an excellent job. They're all researchers over in Australia, and one in Oregon. So that's fun. And they did a really good job on their paper, and congrats to them for finding that out. So that's what I have for you all today. We're gonna take
thank you.
Yeah. We're gonna take a brief break, and when we return, it'll be Victoria.
Strange by Nature podcast is brought to you by listeners like you who have joined the Society of Strange, our membership group on over at patreon.com/strangebynature. Society of Strange members can join at one of 3 different membership levels and help support the show, and also get some fun stuff like water bottle stickers or access to super secret content. So thank you to those who have joined already to help make this podcast possible. If you haven't joined yet, we'll see you soon over at the Society of Strange at patreon.com/strangebynature. See you soon.
All right, guys, I want you to imagine
I'm ready.
that you are a rain gauge.
Oh, okay.
Yeah. So,
Done.
All right. So I'm a little tube,
yeah.
and I fill it with water.
The whole purpose of your existence is to collect precipitation and to measure it.
Okay.
You're made in a you're made in a factory with a whole bunch of other rain gauges. They get sent to places all over the world. So after a long journey,
this is the weirdest intro she's ever done.
Have you checked the name of our podcast?
Yeah. Okay. No, that's good.
So
I'm here for it.
You have a long journey. You arrive at your weather station. You're installed.
Mm-hmm.
You settle down and you wait for some rain to come so you can collect it. Right?
Is it a long wait?
Well, nothing comes on the first day. Skies are completely clear.
Boring.
A couple weeks pass. Nothing happens.
Uh-huh.
Okay, maybe it's the dry season, you think. I'll just wait a few months. A few months pass. Still no rain. Finally, it's been a year, and you have still not collected any rainfall. And with a sinking feeling, you start to realize what kind of a place you're in.
Oh, no.
The desert.
But
not just any
that's
desert.
My only job.
So this
rain.
This anthropomorphized rain gauge was unlucky enough to be installed in the interior of the Atacama Desert, which is
I should have guessed. That's what I was gonna guess.
Oh no!
The driest place on Earth.
Yeah.
A full year with no rain.
Oh, more than that. There is so much extreme about this desert. It's really an amazing place. So I felt like I needed to talk about it. So some quick geographical orientation. The Atacama stretches about 1,600 kilometers. That's about 1,000 miles along the west coast of northern Chile between the Pacific Ocean and the Andes. And so there's some outlying regions that are sometimes considered part of the Atacama, sometimes not. And those include parts of southern Peru, southwestern Bolivia, and northwestern Argentina. So hopefully your geography is good enough. You can kind of picture where we are. So getting back to that year without rain, there are actually some parts of the central Atacama that have never recorded any rainfall. And other parts of the desert,
And
average
how long?
rainfall in recorded history.
Rachel, put your jaw back in place.
That's okay.
Other parts of the desert, the average rainfall is 15 millimeters per year or less. That's a centimeter and a half or
Not
less than
much.
an inch.
Right, over the course of the year,
Yeah.
Woo. So you're saying it's dry.
Yeah, it's dry.
Okay. It's a dry heat.
I was about to say, is it a dry heat?
Well, it's actually
Yeah.
not that hot. I was gonna
No,
talk
'cause
about
it's
that
really,
later.
it's high elevation, right?
Well, not exactly. I'm gonna talk a little bit later
Okay.
about why it's not so hot.
Okay.
But the other thing about this desert is it's old. Some deserts are not that old. For example, 10,000 years ago, the Sahara was more like a dry grassland and was used for grazing cattle. But based on the geological record in the Atacama, it's been dry for an astoundingly long time. So what's called the hyper-arid core, that's the central part of it, has been hyper-arid for 15 million years.
Oh,
What?
Oh my.
I'm sorry.
Yeah.
That was
Whoa,
longer
whoa,
than I
whoa,
thought.
Whoa, whoa, whoa. Did you say million?
Million
years?
with an M, yes.
Million.
And
Okay.
arid, even if not hyper-arid, for at least 150 million years.
Oh,
Yeah,
crackers.
yeah, real dry.
Oh
For
boy.
a very, very long
Yeah.
time. It's been used to study what conditions on Mars might be like.
That's
Fair.
fair.
Yeah. So
What
you might be wondering why it's so dry.
Yes.
You know,
very
Victoria,
much.
I was just wondering, why is it so dry?
Oh, I could tell you.
Yay!
The reason that the central Atacama is so extremely arid is it lies in a double rain shadow. So the prevailing winds for that latitude are from the east.
Okay.
So they go over the Amazon and kind of area of South America. And as the air rises over the Andes, it cools and expands. And cooler air can't hold as much moisture as warm air. So all the moisture precipitates out of the air, basically as snowfall in the Andes. And
Okay.
so then the air passes over, and when it comes down the western side of the mountains, it's very dry. There's the Pacific Ocean
Yeah.
with a lot of water. It's known for having a lot of water in it. Surely that would help. Well,
I feel another rain shadow coming.
Well, we're getting to the second rain shadow.
Okay.
But first of all, the area of the Pacific there has a cold northward current called the Humboldt Current. And it also has a semi-permanent counterclockwise high-pressure system that forces any humid air away from the coast. And in addition, the central Atacama is separated from the ocean by a coastal mountain range that does block any sort of moisture coming in to the interior of the desert. So that's the double rain shadow. However, the other areas of the Atacama do have some fog, so that cold water off the coast can create these dense fogs that'll be blown onto shore at certain times of day and will blanket the coastal region of the desert there. And I'm going to talk a little bit more about what that does mean in a moment. But this double rain shadow for the central Atacama means that in those areas, there are literally no plants or animals that can survive. It is completely barren. There is some microbial life.
Of course
There is some
Why
microbial
wouldn't
life.
there be?
Yeah. It's adapted to the extremely dry conditions, and they actually eat soil nitrates.
Okay.
Yeah.
Why not?
I don't know. Don't ask me any more questions about the metabolism of these microbes because I don't really know.
Oh, okay. Okay.
I'll just shelve
Table
those
that.
questions. Okay, go ahead.
So, in the parts of the desert that receive small amounts of rain and get this fog, life does find a way, though. So there are whole sets of plants and animals that are adapted to capture whatever moisture they can from this fog and use it to survive, which is pretty cool. And similar to what you may have heard about places like Death Valley, when these less arid parts of the Atacama do get rain, there's a super bloom phenomenon where the seeds that have been lying dormant for years use the rain to quickly flower and reproduce, which is a pretty amazing sight from the pictures I've seen.
I believe that. That'd be just phenomenal to see.
And so I mentioned that it was not a hot desert earlier. That cold offshore current of the Pacific is actually what keeps the temperatures pretty cool. So the average summer temperatures are actually around 18 degrees Celsius, 65 Fahrenheit approximately. So it's really not that hot, and it can get quite cold at night. All right, now I get to the sad part. Actually, what I said earlier about the poor rain gauge never having received rain in the hyper-arid center part of the Atacama, no longer exactly the case. So, like most other parts of the globe, it has been experiencing extreme weather due to climate change. And in 2015 and 2017, the central Atacama actually did get some rain. There was no super bloom in the hyper-arid areas, though, because they've been dry so long that there are just no seeds to bloom. So there was some rain, not like a ton by our standards, but a huge amount for a place that never, ever, ever gets any rain. And this filled these ancient lake beds where some of these nitrate-eating bacteria are found. And it was actually devastating for them. It was a mass extinction event for these bacteria.
Oh wow.
Yeah. Because they're adapted to completely dry conditions, and that amount of moisture was just not something that they could handle. They basically exploded. So, things are changing. And it was kind of interesting in the sense of getting back to the Atacama being kind of an analog of what Mars might be like a bit. So, the theory that there might be life on Mars, if it's bacteria that have adapted to a dry, cold climate, it could be something like this. And if humans wind up colonizing Mars, we could be killing the life there without even realizing it. We start getting surface water there.
Right.
Yeah.
Huh.
Wow. Very interesting.
Fascinating.
Yeah, so that's on that note, that's what I have for you on the Atacama Desert today.
Well, I mean,
awesome.
I'm just really just thinking about it's phenomenal that life really, Kirk, you keep saying life finds a way. Like, well, Jurassic Park says life finds a way. But the fact that things have been able to adapt to such dry conditions like that, and that there's been a desert for millions of years in more or less one place, that's crazy.
That's the part that blows my mind the most, is just how long it's been there.
Yeah.
Oof. Thanks, Victoria.
You're welcome. I just wanted to call out an article that I read that was a study on what happened when those rains came. It's called Unprecedented Rains Decimate Surface Microbial Communities in the Hyper-Arid Core of the Atacama Desert. And it's by A. Azua Bustos and colleagues in Scientific Reports. So shout out to that article.
Woo.
Cool, thank you.
Yeah. When we come back from our break, we're going to have Kirk.
So it's funny that both of you kind of were inspired by scientific journal articles this week.
Yes.
Because an interesting journal article came out back in November in the Biological Sciences edition of the Proceedings of the Royal Society. And it was called Punctuated Evolution in the Learned Songs of African Sunbirds. I'm sure, you all read this.
100%.
Sure no one read this. No one read this.
It is on my nightside table. I read it every night.
Oh, good. Well, this is actually an open access journal, so if this piques your interest, just know that you can get the entire article online for free, which is wonderful, and I wish more journals would be open access like this without charging the authors tens of thousands of dollars to do so. Looking at you, nature. Anyways, that's a whole other controversy going on right now, but this story starts off with a thought experiment, much like our thought experiment. I'm not going to ask you to be a rain gauge, but I just want you to think, if we had a time machine and we could go back in time, how many bird calls do you think we would recognize? And more specifically, like, would we recognize bird calls from 500 years ago?
Oh, absolutely not.
How about 1,000, 10,000, 100,000, a million?
No.
Like, how far back do you think we could go
Here's
and still recognize calls of familiar species? Does any guesses?
here's the thing, Kirk.
Yeah.
I'm not good at recognizing bird calls now.
Okay. Okay. Assuming you knew the bird calls in the first place.
All right. I do know a couple.
Okay.
Well, I don't know if that I have a guess even really, but I have a
Right.
sort of a question or some musings, I
Yeah.
guess. I know that there are some species that transmit their calls culturally, at least to some extent,
Mm-hmm.
right?
Mm-hmm.
Because there could be like white-throated sparrows, for example, right?
Oh, we're gonna talk about them. Yeah.
Yeah,
Of course we
so
are.
they have different. You collect a white-throated sparrow from Ontario, and it's going to have a different
Like a
song than
dialect.
the
Yeah.
Minnesota white-throated sparrow or whatever.
Okay.
I don't know. My impression is that that's not the case for all birds. That there are some birds where the call is the same all
Like a
over
chickadee?
its range.
Yes.
Chickadees aren't. No, one of the things we're finding actually, and you can. There's an amazing website called Xeno Canto, which is Xeno Canto, and this is where people, just average citizen scientists, are uploading birdsong from around the world, and researchers are finding out that there's way more variation in like dialects than we probably ever knew before because instead of one researcher,
Mm-hmm.
there's like thousands of people uploading stuff.
I
So
love citizen
um,
science.
yeah, super, super cool. So, like you were saying, though, one thing we do know is that bird calls change over time, right? So, we have documented changes in bird calls in some birds in as short of time span of a human life. Like someone's like, hey, this sounds different than it used to. I even remember it sounding. So, we are actually witnessing real time evolution of bird song in the white throated sparrow, which you mentioned. Many listeners who are birders know that there are essentially two different songs they sing and
Mm-hmm.
one is actually rapidly spreading and taking over the other. So,
Really?
when I was first learning, or some of you are into birds, you might have learned that the call of the white-throated sparrow is "Oh, sweet Canada, 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 Canada." It's kind of the pattern they do.
Mm-hmm.
Mm-hmm.
But there's actually a second song you sometimes hear them doing, which is sort of a "Sweet Canada, 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 Canada." It's like a shorter version, and things are inverted.
Okay.
And that song, that second song, is like climbing the charts and becoming more popular with white-throated sparrows, and
It's
they're
just
kind
the
of
new pop hit.
they're switching over and singing that more, which is kind of fascinating.
Hmm.
But what we don't know is this just the latest change to their call, and these changes happen frequently, or has that call been was that call stable for maybe like thousands of years, and this is just all of a sudden a recent change? And that's like a real thing. Like, how do we kind of tease that apart? So, to put it simply, scientists want to know, is song evolution in birds like a constant gradual change or what we would call punctuated? So, punctuated meaning it's stable for a very long time, and then there's quick, short periods of change only once in a while. And so, this is something scientists have kind of puzzled over. And we can watch single changes happen in real time, but it brings up this interesting puzzle of like, how do we know what bird songs sounded like in the past, especially the distant past? And we may want to know if bird songs evolved gradually or in a punctuated fashion. But in the absence of a time machine, it really does seem like an interesting yet impossible question to answer, right?
Mm-hmm.
Yeah. Like
Now,
I mean, I'm sure if we were able to take this time machine back 100 years, we probably even 200. I don't think
mhm.
we would recognize any of the. We'd be like, oh, that looks like a chickadee. What? What song? That's one of the bird songs that I know.
Well, I mean,
Is
we have written records of people describing bird songs like the
right.
"Oh Sweet Canada, Canada" or "Oh Sweet Canada, Canada, Canada," that one, and so we can look to those sort of written descriptions to kind of get an idea for some bird calls. But yeah, after a certain period of time, if you go back like couple thousand years, there you're not going to find much description of like exactly what bird songs sound like. Although some people
Mm-hmm.
have, I know in the past, attempted to like use musical notation to like record bird songs,
Yeah, I
which
have
is a
that
really
kind of
cool
book.
idea.
It's or I have a book about that, and I can't. Oh, what is it called? They make a certain graph with it too.
Oh, like a sonogram.
Yeah,
Yeah.
I don't
Yeah,
think
very
it's a
cool.
sonogram, is it?
I think that's what it's called. But if you go like on Xenocanto, they have all those little sonograph or whatever it's called, like of each
Sonograph,
bird.
probably. A sonogram is what you get when you're
Sonograph, yeah,
pregnant.
sonograph.
That's why I'm
Yeah,
like,
sonogram is different. Sonograph. There you go. Yeah, a sound drawing. So and there are apps you can get even like on your phone now that will show you the different sonograms of sonographs.
spectrograph.
Sonographs.
Spectrogram.
Sonograph. Woo, spectrogram.
It's called a
Yeah, okay.
spectrogram.
Spectrogram. Yeah, you can get that of different things as well. So anyone who's listened to the podcast a bit will know that one of the things that I really love is when researchers are clever and can figure out interesting ways to tease answers out of seemingly impossible situations.
Yes.
And that is exactly what these researchers did without the use of a time machine.
They didn't use the time machine?
They kind of did in a way. I'll explain it. So the species they chose to study was the eastern double-collared sunbird, which sounds like a single species, but it's actually a whole like complex of closely related species in Africa. And this is a mountain montane bird. And we already know a lot about sunbirds, including that their songs are learned from their parents, just like Victoria was talking about. And so, as opposed to being like maybe instinctual or something. So it definitely has to be passed on, like from generation to generation. So there's at least the potential of songs changing very quickly, right? Because it's a learned behavior.
It's a giant game of telephone.
Exactly. So one of the other interesting things about these sunbirds is that they inhabit essentially islands of habitats on the edges of mountain forests. This means even though there are many discrete populations of sunbirds, they are geographically cut off from each other and have been for thousands of years.
Oh.
And there's sort of the little time machine, right? So, this, provides us with like a geographic time machine, if you will. The researchers were able to compare the songs of sunbirds that clearly shared a common ancestor, but had been separated for thousands of years. And they could compare the songs. So if, for example, two sunbirds have essentially the same song, but they've been geographically separated for 10,000 years, then we can reasonably assume that the song both species are singing is the same one that they were singing 10,000 years ago when they were not separated, right? That makes sense?
Yeah.
So it's a really cool and kind of fascinating idea and interesting thing to study. So I will say, if you read this research paper, they went all out. It wasn't just like listening to bird songs. They were sampling different species, doing DNA sequencing, and doing cladistical analysis to figure out how closely related each different species was. It's a really dense and fascinating paper. And the upshot, though, is that they do believe they can show that bird song evolves two ways, at least in this species. It does change gradually over time, but it can also change in rapid punctuated manner. The punctuated change is probably related to new selection pressures, say like entering a new physical area, whereas slow changes to the song are associated with slow, gradual evolutionary change while a bird is staying in one area. They also noted that small changes to songs that accumulate gradually may not be useful to distinguish genetically distinct populations. However, like big changes in song that happened rapidly probably also correlate with rapid genetic evolution. And I don't think they were saying that rapid genetic evolution and speciation causes rapid change in birdsong, but rather that the new evolutionary pressures that come into a new area can cause both genetic change and changes to birdsong.
Okay.
That makes sense?
Yeah.
There's even talk about like maybe if you're in those birds that are the ones that are most likely to leave and explore a new area, maybe even like need to change their song because they're having to communicate over a larger area with a smaller population. There's some interesting kind of ideas around that. So, anyways, if related birds have a distinctly different song, you can possibly assume they have distinct genetic variation as well, which is pretty neat. So it's all super cool and amazing research. But I have to admit, what really drew me to this story was the question I started off asking you, which was how far back could I go and recognize bird songs, right? So
how
the
far
study
back
showed,
can you go, Kirk?
Well, the study showed retention of song characteristics in populations that had been separate for over 100,000 years.
Oh, wow.
Oh, okay.
Yeah, it's phenomenal. Now, when I first heard about this, I was thinking that meant that like the song had stayed unchanged, and I don't think that's actually the case. I think
No,
what they're saying is that,
characteristics.
yeah, certain aspects or characteristics of the song were unchanged in certain populations. So, I mean, it could be as simple as the bird sings at the same frequency or like sings the same 5 notes, but the order changes. So, I mean, I made that example up, but you get the idea.
Mm-hmm.
It's like there was
Yeah.
definite, they could see those, there was a correlation between those, but it doesn't necessarily mean that you'd be like, I exactly know that. But oftentimes, if you hear a species that's even kind of similar, you're like, it sounded kind of like a bluebird. And you're going, oh, I'm used to the eastern bluebird. It was a mountain bluebird. They have a similar sort of song to them. So I
Okay.
think they're showing that those things correlate.
Yeah.
Interestingly, in North America, because we had glaciation so recently, within 10,000 years,
Mm-hmm.
that caused all kinds of, populations to be broken up and switched around in North America. So I think in order to have birdsong as unchanged for a really long time, you need to not have like um, huge, geologic changes and stuff that's going to make populations move around. Moving into new habitats it seems like what can often spur a change in song. So, anyways, overall, it's a really fascinating paper. The authors go into some, details of looking at what the forces are that could work to keep songs the same, and also why they might rapidly change. But both those areas are ripe for new research and just like really fascinating, bizarre, like ideas coming out of what the forces are keeping things the same and changing. So really exciting area of research that we're hopefully going to hear more about in the future.
Yeah, that sounds really fascinating. Like seeing how what?
Yeah, it's a
Yeah, but
super
until
cool
we get
experiment. Very clever.
until we
as
get
you
a
said.
time machine, that's the best we're going to be able to do.
Ugh. You can't do much better than populations that have already been separated for thousands of years.
Right. Well, that's what I have. That's what we got today. It's funny we all brought essentially 3 different research papers to
More or less.
the strange game today. So thanks for
Woo!
doing that, and we'll see everybody next week.
See you next week, everyone.
Bye-bye.
Bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.